The first topic in geometry talks about the types of angles and their opposites. It talks about the different types of angles in geometry. Let's thoroughly find out exactly what these fundamental angles are, here in this crucial topic of angles. It explicitly states that it discusses specific points formed through a precise set of two intersecting lines with a common fixed set point. And by the way, this particular concept could very well come up in your upcoming examination. For example, it might specifically ask you to clearly define something, or it might present you with a particular question here and then ask, what exactly did it do in this specific space? Just like I meticulously wrote, what precisely did it do? So, the very first and most important thing here, if I were to carefully draw a distinct ray like this, for instance, and then a second, separate ray, when these two rays meet at the same start point, it forms something called an angle here. Here it is specifically called an angle. Here it is also referred to as an angle. And here it is precisely designated as angle A, B, C. This particular point P represents the crucial vertex of the entire angle. Indeed, the very vertex itself. And here, specifically B, A, and C are indeed the respective sides of the triangle in this context. Side in the definitions. It says here, quite explicitly, that an angle is fundamentally defined as the union of two distinct rays. Now, considering that precise definition, do you truly believe that the specific union you've just taken, that is, the union of those two particular rays, specifically ray BA and another ray, accurately represents what is meant by an angle in this context? BA ray, BC ray, union of two rays, union of two rays. It clearly shows us here the union of ray BA and ray BC, because here it explicitly states the union of two distinct rays with a common starting point, which is indeed the definition of an angle. They share the starting point, which is B, which is the vertex, The common starting point of the two rays is known as the vertex of the angle. It's called the vertex of the angle. And he tells you any ray, each ray from a point is called a side of the angle. Each of these rays is called a side of the angle. So each of these rays is called a side of the angle. So I have again, you need to understand, before you look at the curriculum, the lessons, the explanations, the solutions, and all that, you need to understand geometry. Right now, you are like fertile ground that we're still building geometry on, because geometry is all about connecting information. Geometry is not like algebra. So here you have, it says here, BA union BC. You might get a question like that, and also in the book, BA union BC. Here, an angle will appear for us, and a method will show up. What is this method? Method. Before I tell you this, let's solve it. This says, I want the name of this angle. Because you will learn how to read the angle. He said that the angle's name, this symbol, is called angle APC. The angle is formed by APC. BAC, how was it made? ABC or CBA? Or I could articulate this as the specific angle, CBA. Or alternatively, I could simply refer to the central point, the vertex itself, which is B. Indeed, by the immense power and divine might of God, it is B, the designated vertex B. Therefore, to make it absolutely clear, here I am presenting it again, and once more, for complete understanding, here it is again. The name of the angle, or the name of this angle, or what I mean is ABC, or CBA, or angle B. I can't just say AC, that means there's an empty space here. This is the name of the angle. We need to learn how to read the angle, and when I come to read the angle, how will I read it at school? How will I say it? Should I point to it? So you should, I bring the similar repeated ones, then I put A here and C here. If you change it to C and put A here, it doesn't make a difference. This is the name of the angle or the growth of the angle. And this was a question that came up last year for the smart students. There is something called the angle measure, which means the measurement of the angle. When we measure resistance with resistance, when we take the whole thing in elementary school, we say 30, for example, 30A, we say 30 degrees. Where do I tell you? A protractor is used to measure an angle, the protractor. We use it because we measure the angle with the protractor, and the angles are measured in degrees. And we also measure it in degrees. Its unit is the degree. This degree is based on what? If you take a look at the protractor, this is the protractor you used in elementary school, the original one. This is its basic shape. This is its basic form. This is the distinct and precise shape of the protractor, an essential measuring instrument. At every clearly defined mark on this protractor, each individual line meticulously represents exactly 1 degree of angular measurement, commencing from an initial point of 0 and systematically progressing all the way around to a full 360 degrees, culminating precisely up to this specific point here. Because this protractor, which is a fundamental geometric tool, represents a specific and measurable portion of a complete circle, and in the very near future, we will delve into the important mathematical concept that the total angular measure of an entire circle is precisely equal to 360 degrees, a foundational principle in geometry. Alright, that's clear. That's why it tells you that the protractor is used to determine the level, and when we say the level is 40, 50, or 60, so we say, in the end it's 60 minutes, 70 minutes, 60 minutes, and the minute mark is like that. Is there another set, like kilogram and gram and things like that? Is there a different set? Yes. In determining the level, is there a different set? Is there another text available? Yes, there is indeed another distinct set, specifically called avia, which is then referred to as second, and also another separate set called minute. It is important to note that these particular sets are not related to the concept of time. Therefore, it is appropriately called degree, and it's called degree, which is the largest set. After that comes minute, then here is 1 dash, then here is second, and here is 1 dash. There is some information that says that 1 minute is 60 millimeters. At the right time, we have 60 millimeters, which equals 1 hour. At precisely the right moment in time, we observe that we have exactly 60 millimeters. This measurement, 60 millimeters, is precisely equivalent to 1 full hour. Indeed, 60 millimeters consistently equals 1 complete hour. And so at the perfectly opportune moment, we find ourselves with 60 millimeters. This specific measurement, 60 millimeters, is without a doubt equivalent to 1 entire hour. It equals 1 minute. So we have units that are different from degrees. We have degrees. Then comes the minute, then the second, degree, minute, and second. And of course, this can be solved using the calculator. These things are available on the calculator, and we'll cover them at the appropriate time. Now let's move on to the very important topic, which is the types of angles. This is basically the core of the lesson now. Types of angle. Types of angles. You covered these things in the early days. You learned some simple things about them. You have the very first desk. Please do not forget that any desk is truly for a specific desk, a dedicated desk for a desk which you indeed possess. There are certain things they commonly call libraries, and this initial desk is specifically for a desk that originates for a desk. There are many other interesting things here. Zero angle means more angles. Its name is zero angle, and it got its name because the major discovery was its discovery. 0 degree, and I want you to focus and pay attention to everything. If you look closely, you'll find that this is the angle. I'm not sure I understand. This particular logic is very much like a ray, a singular beam of light going in this direction and then that direction. Now, where exactly is the second ray? I ask again, where is this elusive second ray? Is the second ray truly present there? No, it is certainly not there. Wait, upon closer inspection, it actually is there, but it's merely sitting directly on top of this initial one. Why is this the case? Because it hasn't moved at all from its original position, and that is precisely why its measured value is equal to an absolute 0, its precise measure. It stays equal to 0. There it is. Right on top like that. So its measure is equal to 0. It's like a car, for example. Your car. Or say you see a car that hasn't moved at all. Right now, it hasn't moved, so there's no speed. And if its speed is 0, it doesn't move. And likewise, the side doesn't move. So if the side doesn't move, that means the measure of this angle is 0. 0 degrees. Then you have the acute angle, and the measure of the acute angle is between 0 and 90. And we took this whole thing. At the start, it's between 0 and 90 degrees. The measure of the acute angle is compared between 0 and 90 here. It tells you to read more than 0 degrees, specifically greater than 0 degrees and less than 90 degrees, which signifies less than 0 and less than 90 degrees overall is indeed less than 90 degrees. Now, when we consider the acute angle, which is a type of angle, it typically looks like this, often appearing as a sharp, pointed corner. It generally looks just like the familiar letter V. This concept can also be clearly and effectively presented to you in this particular manner, allowing for a comprehensive understanding. In the shape of the letter V, the acute angle is between 0 and 90. That means any value greater than 0, like 10, 20, 30, 40, 70, 80, 89, 89. What will it be? At 90, it will be an acute angle. It will be an acute angle. So that's the acute angle. It's a measure between 0. It is compared with 0 and 90. Now you still have the angle. Here the angle is specifically fixed. There are certain angles whose particular measures are constant and do not change, indeed remaining perpetually the same. For example, like what? Its measure is 90 degrees. The exact measure is precisely 90 degrees, and the measure consistently remains 90 degrees and does not change at all times. It is simply 90 degrees, nothing else, absolutely. There is no disagreement about that. It doesn't increase or decrease. And to distinguish it, he draws it for you like this in the diagram. For example, if he shows you something like this, this is it. This is the phase, the rest phase. If he shows you the rest phase, that means this is the rest phase. And the meaning of the report will be 90 degrees. The meaning of the report will be 90 degrees. He tells you here, the rest phase, the rest phase, the rest phase, always an independent report. 90 degrees. And you have the excitation phase at a certain degree. By the way, each time the angle increases. And if you notice, you'll notice that these two sides move farther apart each time. The more we increase the angles, the farther apart they get. Now, let's talk about innovation here. The range of the innovation. It becomes more than 90, and less than 180. It becomes greater than 90 and less than 180. So the range of the innovation is more than 90 and less than 180. This is the direct phase. To properly distinguish it, you absolutely must find that these two distinct entities are indeed different. You absolutely must clearly identify that these two entities are fundamentally different. Allow me to provide you with some illustrative examples: 110, 100, 170, or perhaps 108. In this particular case, this is what we refer to as the direct phase. If you want to understand, don't just memorize. I'm not going to give you just information or studies. I'm not letting you leave today without fully understanding everything. We absolutely must see it at least 3 distinct times within this specific and crucial area. It is imperative that we observe it 3 separate instances in this particular and vital region. We truly must witness it 3 individual times throughout this designated and important zone. We undeniably need to see it 3 distinct occasions within this precise and significant locale. We are compelled to see it 3 separate moments in this very important and defined territory. Do you genuinely want to proceed with this critical observation? Do you really see up to 180 just to look in one way, a phase line, and a line out 180? We are talking about the truly significant bone, which is indeed the largest bone, and this is something you most likely haven't heard anywhere else. And if you've heard about it throughout the entire period of your studies, it is precisely called the reflex angle. Reflex angle is called the reflected angle. So where exactly is this not the case, or where does this principle not apply? Allow me to elaborate and explain to you. For instance, consider this scenario. When I present to you a specific angle, such as this one right here, clearly visible? Yes, precisely, mister. That is correct. And I have previously informed you that its precise measurement is a certain value. Specifically, how much is it? What is that exact measurement? I explicitly stated that its measurement is exactly 60 degrees, a precise numerical value. This means, unequivocally, that the numerical value representing the measure of this particular angle is indeed 60 degrees, pertaining directly to this outer angle, clearly distinguishing it from any interior angles. To this outer angle, that's what I want. If you had been paying attention a little earlier before we started this page, you'd be able to tell me, I don't understand. We have something called, it's kind of like a circle. Altogether, it makes 360. Didn't I just explicitly tell you that a little while ago, just a moment ago? The essential knowledge that the protractor instrument provides is fundamentally to comprehend and fully understand what the protractor precisely tells you, the crucial and fundamental knowledge that the protractor instrument consistently provides and offers, the comprehensive and vital knowledge that the protractor instrument reliably provides, giving us essential information, the indispensable and significant knowledge that the protractor instrument unfailingly provides, offering clear insights. In this specific context, the term equivalent truly means and signifies to café, indicating a direct correspondence. Corresponding to the measure of 4 distinct right angles, each measuring exactly 90 degrees, 4 right angles. Don't get bored. Don't get bored with the information you're going to receive today. Don't get bored. Equivalent of 4 right angles. 4 right angles. This means it doesn't matter. We have the rules for the circle or the accumulative angle. 360, yes, it will be equal to or equivalent to it. 4 right angles. When we consider 4 instances of 90 degrees, which is the measure of a right angle, and combine them, we arrive at a total angular measurement of approximately 360 degrees. This complete rotation is a fundamental concept in geometry. This particular point often serves as a foundational question for various examinations, testing a student's basic understanding of angular measurement. Furthermore, I pose this as an engaging question for the comment section below. What is your precise and comprehensive definition of a circle? It's a shape that is approximately 360 degrees, and also the fundamental definition of a circle is approximately 360 degrees. I can precisely determine the various angles involved. From the outside, it appears to be about 300 degrees. Look at this angle. I'll tell you that you need to determine the angles. ABC, you need to determine the angles. ABC, you must. Quickly determine the angles of ABC whenever you hear the word angles. You determine the angles 360, 360 minus 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 360. You do subtraction from 360, you use the calculator and do it. You do it. 360 minus 360, 360, 360 minus. The specific numerical value we are focusing on is 135. This number can be broken down into 100 plus 30 plus 5, representing a precise quantity. And you click on SD, which typically stands for Standard Definition or Secure Digital, depending on the context of the application you are currently using. This action is crucial as it initiates the process of either selecting a specific quality setting for your video playback, ensuring compatibility with older devices, or perhaps accessing files stored on an SD card. By performing this simple click, you are making a deliberate choice that will influence the subsequent display or data handling within the system, thereby guiding your experience towards a desired outcome. whether it's optimizing for bandwidth or retrieving important information. It remains precisely 307.85. That's 307.85. This specific numerical value is crucial for our understanding, isn't it? Now let's carefully observe this next part. It explicitly states 89 degrees and 60 minutes. It's very important to keep in mind, as we have previously emphasized and mentioned before, that 60 minutes unequivocally represent 1 full degree. Yes, indeed. 60 minutes are precisely equal to 1 complete degree. This fundamental conversion is a key concept. The dash symbol here distinctly signifies a separation or a continuation, indicating a specific relationship between the preceding and succeeding elements. And that's the entire explanation for it. And you can specify the usages to achieve the usages. 1 single degree. Here, we're going to carefully add just 1 more degree to the existing 89 degrees. So what precise numerical value do you ultimately get? 90? You unequivocally get the value of 90. And what exactly does this significant number 90 represent in this particular context here? It is universally considered and recognized as a perfect right angle. So, I am clearly telling you here that if you take the full 360 degrees and subtract 90 degrees from it, this mathematical operation gives you precisely 270 degrees. Now, again, if I want to carefully demonstrate how to do it with the aid of a calculator, 60, the most profoundly important thing to grasp is that you fully understand the underlying concept and process. 60 millimeters is equivalent to precisely 1 minute in this context, so we must carefully and accurately add this value here. Now, if I wish to perform this calculation using the calculator, specifically if I intend to execute these operations on the calculator, please observe closely here, and I will meticulously demonstrate to you the exact procedure and what steps you need to undertake from this point forward. Pay very close attention to the detailed instructions I am about to provide. Look carefully at the screen. I tell him here 360 degrees, okay? Okay, I'm telling him 89 and 60. 89, all right. We're going to press on a really important new feature we have available today. These specific buttons, this particular stack, this other stack. Please focus with me very carefully. This exact stack. Click on it right now. Now, the calculator intelligently recognizes this numerical value as degrees. It accurately recognizes this number as well. We press 60 and then press the minute button, so now the calculator clearly recognizes this number as minutes. Press equal and it gives us 270. You get it right away. Again, mister, again. Don't forget that we're finding the reflex angle, the measure of the reflex angle. And to find the reflex angle, we do a subtraction from 360. Okay, so here I say 360 minus. This one is quite easy. 89, 89. And I press here on the comma. After the comma, now the calculator recognizes this number as degrees. Okay, now press 60 and also press the comma. The comma tells the calculator that this number is in minutes. And if there are seconds, you do the same thing. Press equal, and it says here 270, so the answer here will come out as 270. You absolutely need to make a definitive decision regarding the precise levels, all the various and distinct levels of assistance. Here, it clearly tells you that you must firmly decide on the appropriate levels of assistance. Should it be a complete zero, or a certain and specific amount, or a truly accurate measurement, or a definite and unambiguous value? Look closely and focus your full attention with me. When you obtain and observe the levels positioned at a precise 90 degrees, when you get the levels at exactly 90 degrees, we will meticulously draw a very specific and detailed diagram that accurately represents the situation at that exact 90-degree orientation. You will undoubtedly find that it precisely points you directly toward the correct and designated station. Any number that is specifically less than 90 will most certainly and without question be located right here within this immediate vicinity. However, if you happen to take a number that is demonstrably greater than 90, this is called an obtuse angle. However, if an angle precisely measures 180 degrees, it is universally recognized as a straight angle, forming a perfectly flat line. Conversely, if an angle measures more than 180 degrees, it is then classified as a reflex angle, extending beyond a straight line and curving back on itself. So, look at this, 90 degrees. Less than 90 degrees. 90 degrees is absolutely correct. 180 degrees is also correct. These two values effectively swap roles. 180 degrees is indeed correct. 90 degrees is also correct. Taken. If it's less than 90, it will be less than 90. 90 is correct and more than 90 will also be correct. But on the condition that it doesn't exceed 180. If it's more than 180, then here it will be reflex. If you understand this part, you'll be able to analyze it. Look here, 57, 57. First, ask yourself, is it greater than 90 or less than 90? Of course, it will be. We are currently observing a measurement of exactly 60 degrees. This could pertain to an angle, a temperature reading, or a specific directional bearing. It represents a precise and notable value within its respective scale. 60 degrees. 60 degrees. 60 degrees. 60 degrees. 80 $180 and 2. On the calculator, it says 180 and 2. So what type of angle is it here? I told him, Mr. 180 means straight. Sorry, that's a rookie mistake. 180 and 2. Here I have 2, as in 2 minutes extra. That's 180 and more. So you take the angles after 180, which are reflex angles. So here you have a reflex angle. Please focus and take it easy. Let's go over it again. You have this angle. Yes, we did it on the calculator. All right. It gave you 180 and more. 180 is straight. Okay. But here, there's more. An extra amount over 180. So it becomes a reflex angle. This question is also for the smart ones. So the types of angles. If you get 90, it's a right angle. If you get a number less than 90, it's acute. If you get a number greater than 90, it's obtuse. Now, if you get 180, that's straight. If you get a number greater than 180, that's reflex, and so on. Now, please concentrate with me right here. I want you to take a look. Here, it starts to test your understanding and your intelligence. In geometry, it's not necessary that what you study is exactly what you'll see on the exam. That's not how geometry works. Geometry requires you to focus and connect your information. What is it telling you? It says, find the value of x in each of the following. I want the value of x in each of the following. If you look at the drawing, you'll see it's a right angle. You start thinking to yourself, right angle. How did you know? The teacher told me that when I see a square corner, that means it's a right angle. And besides, it actually looks like a right angle. No, wait, is it not a right angle? Its measure is 90 degrees, yes. So what do you want? I want the value of x. Oh, what? Well, I can just set this equal to 90 degrees. That's because to find the value of x, you have to put it into the equation. We just learned this in algebra. Mister, what? What's this got to do with anything? No, that's the kind of thing we used to say in elementary school. What's this got to do with anything? But now this year, all your math is mixed together. All of it is connected. It's all related. Don't say this is geometry and that's algebra, that it doesn't matter. They're all connected. So let's analyze them. We also redo 3xd and 5xd and redo 90, but I forgot. I forgot. We want to analyze the equation, and we said the first thing we do is sacrifice it. We take control over it. It's the constant. The constant is that number that's written in this unit without any letter, and we put it there. If you have 3x, you would simply put 19 minus 15. If you have 3x, you would then proceed to calculate the difference, which is a straightforward subtraction. By carefully putting the number 19 minus the number 15, you will ultimately get the significant result of 75. Here we are going to meticulously examine the technical techniques, specifically technique number 3 and also technique number 3 again, and then with careful consideration, we will bring this particular discussion to a comprehensive close. So the X will clearly show you. I'll carefully erase the erasing that was previously there, and he specifically said 37, then 75, followed by another 75, and finally 3 will indeed be 25. So you were about to create erasing money? I mean, I don't understand, but I'm surprised. I want to stop. I want to go back to the early days to stop these things. Don't you truly want to grow up? Oh, don't you genuinely desire to grow up? Forget about it. Didn't you really want to tell me? How many times did I explicitly say grow up? Didn't you actually grow up? And then what exactly happened? So now we've carefully brought this, the specific angle, and we have meticulously made it precisely 90 degrees, and we have successfully solved the entire equation. So what happens now, precisely? Understand and see. See what? Should I set it equal to? No, it was a red time. What should I do? I don't understand. I don't know what to do. He wants the value of x. Come on, let's take it from below. Here you go. All right. When we went down below, we solved it. What does that mean? He did this for you here and told you that this angle is x plus 5. Yeah. And then he did this angle for you as well. Yeah. What is this? This is the reflex. With 3x minus 1? Yeah. He said no. He brought you all of these angles. We have, do you want some information? It says that the angles are, no? So these are the supplements of the angles? Supplements of the angles? Supplements? What are the supplements of the angles? It means angles gathered around a point. They're all gathered at this point. All these angles together make 360. These two together make 360. We'll do just like we did in the previous problems, but in the end, we'll set it equal to 360. You mean, sir, are we going to take each one separately? No, both together. Both together. I don't understand. So we'll take 3xd minus 1d, yeah? And this one with it too? No, the x plus 5d, how nice? And set it equal to 360? Amazing! There are still many more problems to go. Therefore, since there are angles within a geometric figure, we have to simply add them up to 360 degrees, which is a full circle. We will then proceed to add 3x to 1x. There's a 1 here, just to clarify, by the way. 3x plus 1x. The coefficient of 1 is explicitly shown here for clarity, so that's a total of 4x. And in this next part of the expression, we have the numerical terms, specifically 5 minus 1, the constant terms 5 minus 1, which simplifies to 4. And that means it's approximately 360 degrees. Solving with the equation is basically done. The idea of the problem is solved. Now you just need to continue solving with the equation. We'll move the 4 over there with a minus, so 4x will be equal to 360 minus 4, so 4x will be equal to, C would be 350. We divide by 4, and we divide by 4. 4. So what will x be? Let's grab our calculator and check. 356 divided by 4 will be equal to 89 degrees. So here we'll have 89 degrees. It's possible. Can I repeat it again? Sorry, not at all. Let's take it again. Copy. Here we go. We said this is called the accumulative angle, which means these two must be determined in the first place. The angle he gave you, what's its measure? He gave you this one. And these together, he gave you the whole thing for 360. I tell him here, by the way, you might turn out to be smart too. How? I add them all at once. I tell him x plus 3x. Here you get 4x. 5 minus 1, 5 minus 2. Here you get 4. All of this, the sum is 360. But how exactly? As I previously told you, we can certainly do it mentally, in a manner similar to this. Geometry, as a subject, is a whole and entirely different science. And honestly, if you just truly understand its fundamental principles, meticulously build your foundational knowledge, and patiently take your time with each step, you will undoubtedly get much better and more accurate answers than if you try to do it all at once. For example, 3x plus x is indeed 4x, and 5 minus 1 is also 4, but the quadrants are perfectly good, so we will carefully put 4 here. If 4x were to be 360 minus 4, then 4 would indeed be a negative value. If 4x is precisely 360 minus 4, it would then be exactly 356. We will proceed to subtract 4, and subsequently subtract 4 once again. B89 is successfully achieved, marking a significant milestone in our process. We are continuing forward with the exact same foundational idea and methodology that has proven effective thus far. Let's carefully place it here, ensuring precision and accuracy in its positioning. It's crucial not to overcomplicate things or stress yourself unnecessarily during this step. Maintain a calm and focused approach. Now we will add 30 to this value, treating it as a positive increment, which will further advance our calculation. The final result of this operation will then clearly appear here, ready for our next phase of analysis and application. So, we have the equation. 2x equals 180 plus 30. This simplifies to 2x equals 210. Here, we meticulously divide both sides of the equation by 2, and here as well, we perform the division by 2. We carefully divide, and it clearly appears here that the value of x is precisely 105. I initially made a straight angle of 180 degrees, and I then proceeded to calculate 180. And I solved the equation, because you don't understand. In the end, you say it's alternate. How? No, this is about algebra. If you don't know how to solve the equation, that's a new problem. Let's take a moment to carefully examine this particular situation. May I be permitted to offer a more thorough explanation at this point in time? Therefore, we will proceed to discuss this matter in some detail. Sir, if I may be so bold, could I provide an answer to your question? Please, by all means, do proceed. Did I not, in fact, carry out this task in precisely the same manner as I did on the previous occasion, sir? Yes. What I am trying to convey, sir, is whether it would be permissible for me to gather and group all of these items together simultaneously, and then refer to them specifically by their respective years, for example, those belonging to the 6th grade. Excellent, excellent. Wow, that's great. Show it to the kids. Honestly, it's amazing. Honestly, sir. All right, that's good, sir. So, what should I do? Should I get it done? What will you do? I mean, should I say it? Yes, let's say it. 5x plus 40 plus 170, yes. And I set it equal to 360. Perfect, great. We'll add the constants together since these are constants. It comes out to 210, so that's 5 times. Let's carefully write down the first equation. 5x equals 210. Then we have another instance where we write 5x equals 210. Following that, we encounter a third equation where we write 5x equals 360. We are also given 150 degrees as a separate value. After setting up these equations and values, we will proceed to perform a specific operation here. The next crucial step involves dividing the coefficient, which is 5, from the variable x. We will also divide by 5 on the other side of the equation. This action will allow us to cancel out the 5 on the left side with the 5 in the denominator. Consequently, x will be isolated, and we need to determine its resulting value. In this particular case, after performing the division, the value of x will precisely come out to be 30 degrees. This detailed breakdown ensures every step is clearly understood. So x here comes out to how much? 30 degrees. So that's the value of x. Now you've got it, you understand the whole thing, you get the idea. Someone else might say, Mister, I have something on my mind, but I'm not sure if it's right or wrong. No, go ahead, my dear, say it. Is it possible for me? Maybe I can add those reasons. I don't know if that's correct or not. Can I say that? Approximately 360, give or take a few, more or less, a number that is not exact, but rather an estimation, and whoever is tasked with presenting these compelling and well-founded reasons might reasonably assert that each and every one of them should be meticulously and thoroughly thought out and considered. And he goes back to verifying the uses from 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 the user. I mean, what is it exactly? I don't understand your way of thinking. Write it down. The way you understand it, write it down. Guys, the way you understand this, write it down. That means the steps, the proof, and all that stuff. Write it down. For example, if you can't explain the reasoning or the discussions, you'll have to tell him why, the reason for it, why you chose this, why you gave that a negative sign, and all of that. You have to write it down. That's why you have to understand. I'm not exaggerating. I'm telling you so you pay attention. I'm telling you so you pay attention. No. We will continue with the next question. Here it says straight angle. We will carefully and precisely set the expression 2x minus 10 equal to the significant value of 180. We will then meticulously set 2x minus 10, and we will thoughtfully and deliberately set 2x minus 10, and we will conscientiously set 2x minus 10, and we will finally and definitively set 2x minus 10. And here we can effectively and completely cancel this particular term with that specific one. So what will x be? It will be 50, 95, 95. So the value of x is 95. Here as well, it says straight angle. So I will take here 3x minus 60, which will equal 180. And you continue. This also gives you a reflex angle, or you could call it the accumulative angle. All of them, when taken together, collectively make a grand total of 360 degrees. Indeed, all of them, when combined, truly make 360. If you genuinely want to, you can absolutely do anything you desire, anything at all. You can certainly do anything you truly want to achieve. You can definitely do anything you set your mind to. If you truly want to do something, then anything at all. If you truly want to do anything, if you genuinely want to undertake any action, if you are truly inclined to do anything whatsoever, or in one particular case, someone else might approach it in an entirely different manner and perhaps articulate this very thought to you in their own unique way. Or it could be different, like 2 times together, 150 minus 10, which is 140. You can solve the mathematical equation, 140, which precisely means that 2 multiplied by x is equivalent to 360 minus the value of 140. This calculation will allow you to determine the unknown variable x. So 2 times x will effectively be equivalent to the value of 120. Therefore, we must proceed to divide this entire expression by the numerical value of 2. And then we meticulously conclude and finalize this mathematical equation. It will be 60 minutes. This is a very easy topic, but you keep solving. It's the same thing over and over. We will redo all of this, and we set it equal to 360, or 3x minus 60 and 120. All of this equals 360. So 3 times together, how much is that? 120 minus 60. That calculation, 120 minus 60, the result is 60. Yes, it is 60. Indeed, it is 60. And that makes it 360. We will carefully put 60 here, right here. With the minus, it becomes 3x. 360 minus 60 is 3x, which is 300. So we do 23 and we do 23. Here as well, we perform a cancellation operation, which means that the variable x will then become 150 degrees. Oh, wait a moment, I need to correct that. This value is actually 100 degrees, not 150 degrees, so x is indeed 100 degrees. So if you take the receptors from all these receptors and do it with 360 degrees, is it the same as well? Yes, it's the same, by the way. You're smart to notice that. I could have taken them all at once. So 2x with 3x becomes 5x. And we will do approximately 360, and we will do approximately 360, and we will do approximately 360. This will be a good estimate. And we'll do approximately 360, which is a significant number, and we'll do approximately 365, a full year's worth of days, and we'll do approximately 365. Indeed, a complete annual cycle, and we do it here. Right in this very spot. This entire calculation, this substantial value, is then divided by 5, a crucial step in our process, resulting in a specific outcome. And here as well, divided by 5, we'll cancel this with that. So x comes out to be how much? 71 degrees, 71 degrees. So what do we do with this problem? You'll say, I don't know. No, come on, that's not fair. That's not fair. This is the angle. This is the angle itself. He told you here, the AC, and then he said, Mr. AC and the letter T. What is this letter T? Isn't this an upside down T? An upside down T? It's normal. We've done this before. That's what it's called. This is called the perpendicular. This particular symbol is not present here. Please do not consider it here. You typically encounter it in elementary school. You learn about it in elementary school. It's specifically called the preventicular. It's indeed called the preventicular. Yeah. I'm not entirely sure. The preventicular. What exactly does preventicular truly mean? It means it clearly shows you right here a perfect right angle, meaning it is perfectly perpendicular, just like this. This forms a precise right angle right here, exactly 90 degrees. He says this is a correct verification with 90 degrees. Yes, what is this symbol? It's he says here, a perpendicular stop like this at 90 degrees. Yes. No, I understand. Yes. 4x plus 55 plus 7, we take it all at once. So 4x, come on, let's write it down for those who remember it as well, equals 90. After that, read that 4x is more than 55, which means it will be a reason later on. You will find that it will be a reason later, so you need to focus on the position and state the reason. You will find that 4x causes 90, which means it will be a reason later, meaning that 4x causes 8. So let's put that in this part. We make adjustments between the 4 and the 4, and we control the position, 7 degrees. So the value of x here comes out to be 7 degrees. You're gaining information and skills, you know? If up to this moment you understand every word, then you're doing great. Honestly, you really are. That means you're doing excellent. Come on, boss. Let's go, really. What are we going to do here? 2x plus 2, and here you have x plus 1. Oh, so from this, sir, that means it's a right angle. Right angle. What's its measure? 90 degrees. Nice. So, sir, can I just do it all at once? So, we have 2x plus 1x. And here, as you can clearly see, there's a 1, which means that's a total of 3x. And then, on the other side, 2 plus 1 gives you a total of 3 here, which then ultimately equals 90. And if we carefully move the positive 3 to the other side of the equation with a minus operation, you will then have 3x remaining, which precisely equals 90 minus 3. Are you perhaps starting to get a little bit bored with this explanation? Are you getting bored with these calculations? So therefore, 3x equals 90 minus 3, which as we calculate is exactly 87. So from this point here, we can proceed. Here, we apply a force of 3, and here as well a force of 3. We will connect this with this, so what will the x show you? This will show you 29. It will show you here as 29 degrees. I hope you understand this, because you need to understand what he told you. With the plunge of the ick, important information, very important information. Man, what does plunge of the ACD mean? It means P is on the same line as AC. What does that mean? I still don't get it. It means that here we will have a straight angle. So, the perpendicular line will be right. And here the meaning of P plunge of the AC is that it's on the same line as AC, which means this will be a straight angle. Well done. That's deep. 180 degrees. Yes, these are keys. These are keys that help you in geometry. You can use these two together. Let's write them together so you don't get confused. We have 5 x terms combined with 4 x terms. That's a total of 9x. I have the constant term 2 with the other constant term 2. That's a resulting value of 0. The entire expression, when simplified, ultimately equals 180. That's precisely what was stated in the problem. Therefore, to solve for x, we proceed to divide by 9. And so, to determine the value of x, we proceed to divide both sides of the equation by 9. We divide by 9, so x ultimately becomes 180 divided by 9, a straightforward calculation. Let's truly learn something significant and valuable from this mathematical operation here. Adding to that, the AC will be a line segment, and its name is CB. They are on a line segment, meaning A, B, C are on a line segment. They are on a specific segment of interest. A straight line segment, which is a part of a line with 2 distinct endpoints on the same line. I hope you understand. Okay, now this part, it's the same idea as well. Also, along AC, that means right here, this is a straight angle. A straight angle is exactly 180 degrees. Let's carefully take these two expressions together. Come on. 4x plus 1x is indeed 5x. 8 and 2 make a total of 10. 8 and 2 will collectively equal A, the number 10, and all of this will ultimately equal a grand total of 180 degrees. We'll move the 10 here. With a minus 5x, it will then equal 180 minus A, the number 10. Therefore, 5x will equal 170. We will start with 5, and then we will start with 5 again. We then remove the letter D, moving from 33 to 34, specifically 34 degrees Celsius. As for this particular one, I'll also leave it completely for you to consider, or perhaps we can endeavor to solve it together, step by step. It fundamentally means that we need to find the precise prolongation of the line segment BC, which inherently implies that as soon as you visually perceive this prolongation, it will unequivocally form a straight angle. Which specific one is it, you might ask? It is indeed a perfectly straight angle. The fundamental measure of a straight angle is precisely 180 degrees, my dear student. Now what about this other one? It is essentially the very same concept, but, sir, It merely looks visually different. Can't you possibly solve it simply by the way it appears to your eyes? It is quite similar to what we are currently solving, but it is just tilted a little bit, perhaps at a slight angle. I mean, it's like this, yes, if I were to draw it out for you visually like this, but it is still positioned on the very same continuous line. Here, they are all meticulously drawn on one single, unbroken line. Do you see? Just like this one too. Look, he might give it to you like this. The most important thing is that they're drawn on C, A, and B, like this. Now I understand it, it's clear. So it's not necessary for them to be drawn on the notebook's line. The notebook's line? Of course not. No. It's not the notebook's line or anything like that. The most important thing is that they're drawn. He's telling you A, then B, then C. So C, A, and B are all drawn on one line. Look at it like this. The most important thing is that they're drawn on the same line. C, A, and B. So now we know that this will be an image. A method with 100 AD, 10x, and 4x. Here, in this specific calculation, it will become precisely 14x, and then, considering the next part, 5 minus 3. This operation, 5 minus 3, will indeed be different here, yielding a distinct result. Subsequently, we will proceed to carefully add the value of 2, and then set the clock, or rather, the numerical value, to 5. So, after these steps, it becomes 2, followed by 180, and with all these elements in place, we can then effectively solve the entire equation.